Friday. So lesson 48, let's finish it. Indirect proofs. What else do we call indirect proofs? If you've got notes, we've written some things about this.
Proof by contradiction.
A proof by contradiction. A proof by contradiction means we're going to contradict something. We're going to go around about proving something. We're not going to go directly to the mall. Or directly to my house. We're going to make a pit stop at the mall and drive around and then get there. Okay? So it's not a direct route, but it does have three simple steps. You remember those 3 simple steps were? Assume the conclusion is false. That will be the first line. Assume whatever we want to prove is false. Okay? What was our second step? Okay, so we've written out like the official rules. So we're going to find a postulate. Theorem. Could it be a definition?
Yes.
Could it be a property?
Yes.
Could it just be the given information?
Yes.
We're going to find something that contradicts our assumption. This would be a good time to put on the recorder. The words, but already it's too late for that. All right, what was our third step? So we're going to actually make a statement. So we're going to state the assumption has to be true. The assumption is false. The false statement is false. So what happens? So what we want to prove, that conclusion must be true. Okay, 3 steps. If you weren't here last Friday, if you were here, we've already talked about these a little bit. Okay, so let's look at a proof. I think we looked at example 1 the other day, maybe a little bit. So let's go ahead and look at example. Let's look at example 3. Okay, using an indirect proof, or writing an indirect proof. We're just going to look at example 3. Use a diagram to prove theorem 42-1. The perpendicular segment from a point to a line is the shortest segment from the point to the line. Have we done that before? Finding distance. What's the distance from this point to this line? Okay, so we want to prove that the shortest distance is perpendicular to it. Okay? So they have a given. AB is perpendicular to BC. Prove that AB is the shortest segment from A to BC. Okay? We want to prove that it's the shortest. So what's our first thing we're going to do? So what is our conclusion in this case? What do we want to prove, Carter? You're going to assume AB is not the shortest distance. Okay, that's our first step. Assume that what we want to prove, the conclusion is false. So we're going to assume that AB is not. And that's what they do. First, assume like the way they even phrase this. I don't like their descriptions. I'm gonna say, assume it's not the shortest link. So they're gonna assume that another segment from point A to BC is shorter than AB. In the diagram, this segment is shown as AC. Our assumption is that AC is less than AB. So the point out here from A, B was not there. B was directly below, wasn't it? It says that A to C is less than A to B. That could bother me too. Okay. I personally would say AB is not the shortest. But then can we look around? Diagrams are always helpful. What do you know? ABC. So if I were to draw the triangle, A to B to C is what? What do you know about that triangle? How do you know it's a right triangle? The given information told us that AB was perpendicular to BC. So the given information says this angle has to be a right angle. Okay? So let's think a little bit logically. If you have a right triangle, and I'm assuming that AC is less than AB, what are we going to do with side lengths in a right triangle? The Pythagorean theorem, right? That says A squared plus B squared is equal to C squared. But I don't have an A, B, and C, but could I do it with side lengths? AB plus BC is equal to AC. Okay, we need to think about that. Okay, let's see what they say. I go to that. They actually say it, don't they? Since a triangle ABC is a right triangle, the Pythagorean theorem must be true. So AB squared plus BC squared is equal to AC squared. And since AB is greater than AC, that's what our assumption was. That's our assumption. Both AB and AC are greater than 0 by squaring both sides. Yeah, maybe I should have done this one before. I didn't always like how they phrase it. If you square both pieces, the subtraction property says that AB squared must be greater than AC squared. Substitute show that BC squared must be less than 0. Can we have a side length of a triangle that's less than 0? No. Is it a triangle anymore? No, we just said, hey, this is not even a triangle. If this is true, this is not even a triangle. Okay? And we know that the hypotenuse, I would almost go with the rule. Do we have a rule that said opposite the greatest angle, the biggest angle is the longest side? So the hypotenuse, since AC is the hypotenuse, it must be the longest side because it's opposite the biggest angle. Okay? Therefore, what we assumed can't be true. This contradicts what we were given. This contradicts what we have just said. Therefore, AB must be the shortest side. Okay? I still think the book uses too many words, and they don't give enough examples. Okay? So, let's do another one that's not there. I think we did this one the last time. If we look at the practice, let's look at the practice. I want you to write them down, whether you write them down in your notes or on a separate homework sheet. We'll just keep a tally going. We're going to start the practice letter A. Let's look at it and do some actual problems. A says what? So we want to prove. This is what we want to prove. That the measure of angle X is equal to the measure of angle Y. What do we want to prove? All this question is asking for is, what is the first line of an indirect proof? What would be your first line? So, okay, what is our assumption? That's what they're wanting. What is the assumption? Assume the measure of angle X does not equal the measure of angle Y. That is all they want for letter A. Letter B. What does letter B say? Somebody read it for me.
Make the assumption you would make to start an indirect proof to show that AB is perpendicular to AB.
So just the first line again. What assumption would you make? So if we want to prove AB is perpendicular to, was it BC? Or CB? One or the other? So, and this is the beginning of today. So, all we want is that first line. What are we going to say? So, do I need to use the word assume? Yes. If you want to make it sound like a better sentence, we assume that. Or to say, assume. AB, and I'm going to put is not perpendicular to BC. Because that will be the first line of every proof. We will always start with assume something. We're going to assume whatever we want to prove is false. And most of the time, not every single time maybe, we're going to use the word not. Okay? Most of the time we will. What does letter C say? That was a lot longer. Letter C. Go ahead, Victoria.
An isosceles triangle has at least two congruent sides. To prove the statement indirectly, assume an isosceles triangle does not have at least two congruent sides. What case needs to be explored to find a contradiction?
Okay, so this is really asking for the second step. Maybe not. What would you explore to prove? They gave us the assumption. Assume an isosceles triangle does not have at least two congruent sides. What might we explore? What are we going to look for? What about the definition? What does the definition of an isosceles triangle say? What do you know about an isosceles triangle? It must have at least two congruent sides. So maybe we look at, or we're going to find or use the actual definition. Use the definition of an isosceles triangle. They didn't ask us to fill in the whole thing. They're just saying, what would you explore? What would you look for? Maybe it's like that none of the sides are equal. Okay, well, let's see. Are the sides equal? Let's see. Do I have room? Let's scroll up a little bit. Indirect proofs will always be a paragraph. That's the type of proof it is. Two-column proof is a type of proof. Flowchart is a type of proof. Indirect proof is a type of proof. Okay? So on letter E, where they say use an indirect proof to prove that a triangle can have at most one right angle. Okay? So we're trying to prove that a triangle can have at most one right angle. What would our first line be?
Assume that a triangle cannot have at most one.
Okay, so what does that mean? So can it have more than? So maybe that's an instance where I don't put that not. So it says at least one, it can have, let me read it correctly. It has at most one right angle. So how can we assume that's false?
Assume a triangle can have more than one right angle.
It can have more than one right angle. Assume a triangle can have more than one right angle. And sometimes I just like to try to draw it. So I might try to do a diagram. So I'm going to draw a triangle ABC. A is going to be up here, B is right here. I'm going to draw a right angle at B, and I'm going to draw a right angle at C. Okay? So my C is going to be right angle. Also, what happens? It can't connect without another line. But a triangle can only have three lines, three side lengths. Okay? So if I have triangle ABC, and angle B and C are both right angles, what do you know about angle A? What do you know about this triangle, other than it can't exist? Why can't it exist? It has to be closed, but still a triangle can only have three sides. So which one do I create false? Three sides. So if I leave it at three sides, it means it's not connected. Okay? A triangle has to be closed. It has to be a polygon. Yes. Yes. Could we say it has to be 180 degrees? So if we really just think about numbers, okay? Angle A plus angle B plus angle C. What does angle A plus angle B plus angle C have to be? 180 degrees. But if angle B and angle C are both 90 degrees, go back to that original question, what is angle A? 0. Can you have a triangle that has an angle of 0 degrees? No. So there's a lot of things going on in your head. This is still your thought process time. Okay? Second step is what to me. What postulate, theorem, definition, rule, property, whatever, is contradicting what we have just done.
You could use corollary 18-1-4.
Okay? What does it say? I don't know that one off the top of my head.
A triangle can have at most one right or one obtuse angle.
But that's what we're trying to prove. So what's something else? Is there another one back there? Oh, that actually is not the definition of a triangle. Triangle is a polygon with three sides. Okay? But then it's not a polygon. Okay, so we kind of can go a lot of other ways. There's a theorem somewhere that says the obvious. It was back in that 18 dash something. I don't know what it is. But I know what the name of it is because I like the names.
Triangle angle sum theorem.
Is there a triangle angle sum theorem that says angle A plus angle B plus angle C equals 180 degrees? So, if triangle ABC has two right angles. Okay, so if this triangle has two right angles, then what happens? Then, okay, that's how we would phrase this. Grammatically correct is probably a good thing. Sometimes I think about grammar after the fact. Has two right angles, then by the triangle angle sum theorem, by the triangle A would equal 0 degrees. I don't know if I need a word so. Okay, that's probably not the best sentence in the world. By the triangle angle sum theorem, we know this has to be true. So, angle A would equal 0 degrees. Which, we already said that doesn't make a triangle. So does this contradict what we just said? Okay, maybe I need another one. So ABC isn't a triangle. I think that's where I had to have that. It can't be a triangle. This contradicts our assumption. So, what do we wanted to prove? So, a triangle, what does it say, can have at most, the wording they use? At most, one right angle. So, do you clearly see step 1, step 2, and then step 3? Okay? Step 1 is always going to be assume this. What's a postulate in a theorem that's going to contradict it? Last statement will be, hey, this contradicts our assumption. So, our conclusion must be true. Can we do letter E? Can I go on from this page? Okay, never mind. Let's see a couple of things. All right, letter E. Letter E says, use an indirect proof to show that angle 4 is congruent to angle 6 if the measures, if M is parallel to N. So this one, it gives me, it's a little bit more clear. What am I given? And what do I want to prove? So there's two lines that are parallel. This goes this way. There's an angle 4 and angle 6. These are parallel. Okay, that's kind of how we start. That's still a good way to start a proof. Okay, so what is our first line of an indirect proof? So now what is our conclusion in this case? So what's our first line going to be? What do you want to prove? What's our conclusion? Assume angle 4 is not congruent to angle 6. Okay. Next line. What do we know? What postulate, theorem, definition, property do we know? Could we use? How are 4 and 6 related to each other? They're alternate interior angles. And what do you know about if lines are parallel? Then those two angles have to be congruent. So, how do we want to say that? Since lines M and N are parallel, by the alternate interior angle theorem, I need to write this down. Since lines M and N are parallel, by the alternate interior angles theorem, angles 4 and 6 must be congruent. So I still need you to tell me a little bit about it. So step 1, step 2, I think we've pretty much said, hey, this contradicts something we already know. We use the given stuff. There's a theorem that says they're congruent. Last step says, this contradicts. Our assumption. So, angle 4 must be congruent to angle 6. This one, I like this one better than I liked letter D. It's more straightforward. It's step 1, step 2, step 3. There's 3 exact steps that we're doing. Okay. We have just a couple minutes. I think this is just a couple minutes. I'm just going to go ahead and assign the rest of your homework. So lesson 48 is what we've been doing. We've just done the practice. And we're going to do numbers 3 through 9. So I'll give you a few minutes to go ahead and start on it. I'll start on the rest of it. So you're going to go back to that last letter E.